Good day, everyone. Welcome to another episode of the series Building the dApp on Cartesi using Rust. So, in the last episode, we looked at installation, bootstrapping, and writing a very simple dApp on Cartesi. And finally, we ended the video with interacting with the dApp we built and deployed on our local machine. We built the dApp where Bob was able to send an input to a dApp on Cartesi and have the dApp on Cartesi log out the message that Bob was sent. So key things you should remember from the last video is that inputs get into the Cartesi machine as hex and also leave the Cartesi machine in hex format. So that's just a quick recap of the last video. If you missed that video, I really advise that you go back and watch the video. It's just a few minutes. We'll be here waiting. So for today's video, we'll be looking at we'll be going deeper into building on Cartesi, and we'll be writing a new tab today. Today we'll be writing a calculator tab. This tab will be able to collect arguments from a user. Then from the argument that a user sends in, the tab will be able to uh, determine if the user is trying to call an addition function, subtraction, or even a division function. Then that basically will be able to decode the function the user wants to call, carry out the execution, and also emit a notice with the results. So yeah, we are moving a little bit further today, and we'll be touching on notice. If you remember from the very first video of this series, we talked about notice, vouchers, and report and what they are. So if this is sounding kind of like weird to you, you could go back to the video and do a quick recap, and come back and we'll be moving further. So without wasting much of our time, let's get straight to coding. Welcome guys. Same as in the previous video where we had to create a new Cartesi project, we'll be doing the same thing here. We'll push up a new Rust project. Then from there, we'll start building and modifying the code base. So if you didn't watch or if you missed the previous video, please go back and check them out, especially the last video. The last video contains all the steps you need to go through to install and to get your system ready to start building on Cartesi. Also remember that if at any point in this tutorial you experience an issue, you have a bug, read the error message. There's always going to be an error message. Check the documentation for the reference to the error message. If it's still confusing, if there's no mention of that in the documentation, then reach out to us on Cartesi Discord and we'll be more than happy to help you resolve your issues. So we're going straight up to bootstrapping our new tab on Cartesi. So guys, we have our new Cartesi tab bootstrap and we'll be going straight up to modify the code of this tab. So remember, since all inputs coming into the tab and also leaving the tab is in hex format, we are definitely going to be needing the hex library. So we go to our cargo.toml file and add the dependency hex is equal to, let's say 0.4. So guys, what I've done now is I've imported hex into this code and I've also imported something new, which is the pass. The reason why I'm putting the pass from JSON library that comes bootstrap with the tab is since we are going to be collecting more than one value from a user's argument. So user interacting with this tab will have to send a combination of different values. It's a calculator. So you need to send in the method you want to call and the values that you want to calculate or run executions on basically. So we're looking at three different arguments. So it's best if we combine this into a JSON object before sending. Since we will be receiving a JSON object from the users, we need a library to help us pass these JSON objects properly. That's from JSON to string that we can use, for JSON to number that we can also use. That's the reason why I added this libraries method pass. So we'll be going straight up to building or adding our logic to this code. So we'll be doing that in steps, so steps by steps. And the first thing we want to do is to convert the hex to string or to from hex to a JSON object basically. So we'll be converting from hex to a JSON object. Second is we'll be extracting the different arguments we need. That's the method, the values that the user wants to run calculation on. That's the second. Then third will be carrying out the execution. That's what we've gotten all the values. You carry out the method, or you call the method user intends to call. Then the next is we convert the results back to hex format. Then the final is we are going to be emitting a notice with the result. So let's just write that out here. And so guys, we've been able to, first of all, convert the text payload we receive to byte. Then from byte in the second line, we are converting that byte to string inside here first. Then from string, we are directly converting it to a JSON object. So since a JSON object, we can now go down to extracting the different values that we need from the argument. So we are done with this next section. And what we did here basically was to extract the method. We are calling the JSON object, calling the method. Then we are automatic, because once you call the method on the JSON value, it's also returning the JSON value. So what we did here is to convert it to string. So we are requesting that it's given to us as string. Once we make that request, we are getting an option. So the next thing is to extract the value inside that option using the expect. So what the expect does here, it extracts the value inside the option. Then if there's an error extracting that value, it returns a message to you, an error message to you, and that is the error message you passed in when you call the expect. So that's what we did for method, for value, and for value 1, and also for value 2. So we are converting this to a float type. The reason why we're doing this is so that in the when running your execution, if there's any reminders, it won't be an issue returning the reminders to you, because since it's float, that means it accepts decimal places. So even if you pass in a straight number like 10, 1, 7, we are still able to convert it to a float by just adding 0.0 to the end. So that way we have a very safe calculation that can pick up the little decimal places at the back. So we'll be moving on to running the calculation. So guys, what we did here basically is we first of all create a variable to hold the result, and we are using an option as a data type for that variable. This one we're using an option is an option can either contain a sum or a non-value. A non-value is when there's nothing basically there, there's no response, there's no value, just a none. So if by default this result has a non-value, so it means there's nothing in the result, there's no value to return to you. But if you're able to carry out a successful calculation or execution, you are going to be returning a sum. So it's going to be some, look at it as a container containing a value. So it can either be a value, a response, or a result in a container called sum, or as none, meaning there's nothing there in the result. So then the next thing we are calling on the match method. We are matching on method. Then we are checking if, okay, if the user is calling an addition function. If it's an addition function, we are assigning results to the calculation basically. If it's a subtraction, result should be sum, then the calculation of value minus this value 1 minus value 2. Then the final thing we have is an underscore. The reason why I'm using an underscore is at this point, if the method is not addition, subtraction, division, or multiplication, then just print in and tell the user that okay, there's an error basically, or this is not a valid method. So you could just use a more detailed error message here and say this is not a valid method. Good. So any other response or any other method aside add, sub, div, and multiply is going to print this error or log this error on the console. So that's what we've done here basically. So the next we'll be doing is to convert this result we have, since we are expecting it to be an option. So we are converting this option now to a hex value. So guys, we've been able to convert this result to hex. What we did basically, first of all, is to print out the result so we can see what the result is before we converted it to hex. That way, if there's any error, we can easily debug where the error is coming from. Then the next thing we did here is to convert the result to hex. So we are using this method that is built in a Rust code format. So what it does is it collects two arguments. One is the structure in which you want to format your response. Then the second is the data itself you want to format. So we give it a structure here that, okay, we want you to convert this to this type. We want a 0x prefix. Then any other thing, the data we pass in, replace this curly braces with that response. It's more of like when you print and you're like, okay, you're putting a curly braces here to print, and Rust, the cargo basically on under the hood, basically what it's doing is it's replacing these curly braces with the result we passed in here. So it's going to be the same thing. So what we did here is the result. We remember it's an option. So you're using expect to convert that option to a float type. Then from a float type, you're converting it to a string type. This one I'm converting this to a string is just so that it's more readable and we don't have any issues on the front end when we're picking this up. So on the front end or on the terminal, you can easily just convert the string to back to a number type and use it in any execution you want to do. So if paraventure, what we have is a non-data type on results, we are going to hit an error message here with this aspect. So the code will break and we'll receive a message on the terminal saying failed to convert results from sum to a none. So it might be more accurate to something like to match on this results type. Then if it's a sum type, you do this execution. If it's a none, you move on and do nothing. But just to make this simple and just to show you guys the power of these formats, I'm going through this method. So after doing that, the next thing we are doing is to print lin, and we are printing the response in hex. Now that we have the response in hex, what we are going to be doing next is to emit a notice with containing the result. So what I did in this last section basically is, okay, the response we want to send out, I converted it to an object. An object, I will be changing this to payload. So an object containing the payload, the key method, the key name payload, and the value of the result hex. Then the next thing we do is we create a HTTP request to the notice endpoint. So we are creating a HTTP request to a notice endpoint, and this is going to create a notice for us. And we are passing in the response. We are dumping the response here. And the next thing we are doing is we are sending that notice and awaiting this request. Then we are printing the status of this request out. So if you notice, I copied this from down here, and the reason is by default we already have the code for this inside the main function, and the only difference is the code for this inside the main function is sending its own execution to the finish endpoint, but we are converting ours to, we are sending ours to the notice endpoint. So with that, we are done with the logic for our code, and we'll be moving on to build and also run this code. So if you remember from the last video, we're using the Cartesi build and also the Cartesi run command in order to build and run this. Then we'll be interacting with this from another terminal. So guys, we are trying to interact with this dApp. We are passing the method add value 17 value to is 3. So we're expecting that if this should run successfully, we should get a response of 10. So let's run this and see. And yep, so if you look at this, we have result is 10. Result as hex is 0x10. That's because we've converted it to hex. Then emitted notice with response 201 created. So with this, we have our response in the terminal, and we've also emitted a notice containing our response. So we know this calculator basically is working, and we can run calculations like addition, subtraction, and also division. So guys, we've been able to emit a notice, but at this point, we only know we emitted a notice. How do we get a notice? So remember I mentioned that to get notice, you have to go through the GraphQL server. And if you look at this part of the screen, you see that once you start your Cartesi run command, you have this set of values or this set of links that offer to you from the Cartesi CLI. So the first is the Anvil node, the node where the Anvil, your local blockchain network is running. Then the second is a port for your GraphQL server. So it's a URL link for where your GraphQL server is running. So that's where you'll be able to go and query our notice. Then the third is inspect. Remember, you can either read data from the block from a Cartesi dApp, either through the inspect route or through the GraphQL route. So the inspect route is the second route to read data from our dApp, but we didn't implement any inspect state method, so there's nothing to see there basically. Then the next is the Cartesi Explorer. Cartesi Explorer is just like every normal blockchain explorer you see, but this explorer is majorly for your local network. This explorer here with this link localhost 8080, it's focused on this our dApp now that we just deployed and interacted with. In a few minutes, we'll be going there to interact with this dApp through the explorer to see the notice that were emitted, the argument that we sent to this dApp. Then the last two are the bundler RPC and the paymaster link. These two were added recently to the Cartesi CLI in order to help facilitate account abstraction, aka cashless transaction on the terminal. So if you're on localhost and you are planning to implement account abstraction to make your dApp cashless for users on mainnet, and you need to test this while you're building out, so these RPC links are basically here for you. So you can use this link to test out your execution and be sure that they function the way they're supposed to function without the ease of paying gas on local before you move to a testnet or to deployment. So with that, I would like to take us to the Explorer. So guys, this is the Cartesi Explorer, and as you can see, this is our dApp, our application, total applications and total input. So I sent in 3 inputs to this dApp. I sent in 1 officially, then 2 other outside this just to confirm that it's working. Then what we are going to do is this, we are going to look at the last execution we interacted with. So let's see, we'll go to view our input, or you can use this route to see the input. Then we're going to click on this 3 minutes ago. Then you can see this is the input. In raw format, it came into the dApp as a hex. So that's the hex we're seeing. Then in text format, this is the method we sent. And remember, 7 and 3 addition. Then as JSON, this is it, 7 and 3 as a JSON object. Then we emitted a notice, and that's why we have this here. And the notice is in raw format is 0x10. In text format, it's not, and in JSON format, it's not just because these are basically, this is not formatted as a JSON object. So there's no way it's going to give you a JSON response. But as a raw format is 0x10, and we don't even need to move this to a hex to string converter to get the response. You can basically see it there even without the OX. Once you take out the OX, you're getting a 10 response. So OX10 in hex is same as 10 in the readable string. So the next things we have, set of sections we have here is the reports and the voucher. So if this execution had in any way triggered a voucher or a report, we are going to be seeing those here on the screen. So that is that for the Explorer basically. The next thing I want us to look at is the GraphQL. So this basically is the GraphQL server, and it's a GraphQL interface that you can use to query the GraphQL server to get notice and vouchers and reports if there's any emitted from our dApp. So it already comes with the query already written out for a notice. So what we just need to do is to click on this OK, and you can see we have two executions, two response here. The payload will extend and another payload here will extend, and this is how to fetch notice basically. So for this implementation, since we're on local, we are going straight to the GraphQL server and querying this. But in terms of when you have a front end running, you won't be using this method. When you have a front end running, you can take this body and use SDKs like Apollo SDK or just a normal URL call, but it's always better to use already existing SDKs. So you can use SDK like Apollo SDK to query this GraphQL server, passing this query as the body, and it's going to return to you the payload. Then you can extract this payload, display to users on your front end, and users can interact with this as a normal dApp. So going back to our code, we've been able to build a simple dApp, and all our interactions, all our execution were written out in the handle advanced function. We're able to convert user input from hex to JSON object, then extract the different methods and the different variables we need, run the execution, the calculation basically, then convert the result back to a hex format. From hex, we are emitting a notice containing the value. So remember that if you are to emit a report or a notice, you structure this the same way. Then go to this part, replace notice with reports for reports, replace it with vouchers for voucher. Though the structure for your voucher is going to be different, we are going to be seeing this in another video in the same series. But for now, we'll be capping this video at just emitting a notice. Also, if you want to get the structure for this notice, you can always go to the Cartesi documentation to get the structure, to copy it out. Or more easily, you can just scroll down to the lower part of this code, the main function. It comes with the dApp once it's bootstrap, and copy out this line from response all the way down to println. Then you edit this to serve for the purpose you want to use it for, and that's all. So for now, we just scrambled everything, all the whole functionality inside the handle advanced function, which might not be so in when you're building out your own dApp. You can choose to take this out, structure this properly, put them in other smaller functions that this handle advanced function can call and get response. But just to show you how to build and interact with this dApp on Cartesi, you're choosing to go through the easier route. But in the next video, we are going to be doing that. So in the next video, we are going to be expanding knowledge with notice and also reports. So you're adding something new this time. You're adding reports. I'll be writing out of complex dApp that also collects argument as a JSON object. But this time around, we'll also initiate storage. So we'll be able to have a persistent storage in our dApp that users can interact with, get a response, get notice, and stuff like that. So make sure you stay tuned for the next video, and see you there, guys. And most especially, remember to stay rusty, guys.